Hey everyone, Nick Dearbird is here teaching you financial modeling. Today we're going to be solving the lab exercise for adding Monte Carlo simulation to an existing Excel model. This is part of our lecture series on Monte Carlo simulation. So this lab exercise comes at the very end of this lecture series, and here we're taking the Project 1 model and extending it using Monte Carlo simulation. So here we're concerned that the number of phones may be incorrect. Each machine may or may not be able to produce as many phones as we initially expected. And so we want to vary that in the simulation. And we want to run the simulation and then bring the results back into Excel and then visualize the results in Excel. So let's go ahead and jump over to take a look at this. So I have the Project 1 Excel model and a fresh Jupyter notebook that we can use to do the Monte Carlo simulation on the Excel model from Python. So I'm going to import Excel wings here to help us connect Python and Excel. And the first thing that I'm going to do is look at how we can change the number of phones in the model. So we can see the number of phones is here in B4. And so we're going to target that cell. But before we can even get to inputting into that cell, we have to get connected to this workbook and to this worksheet. So first, I'm going to get connected to the book, which is phone manufacturing model. I just realized these are not in the same folder, so that's not going to work correctly unless I put the full file path. And so I'm just going to quickly copy that into the correct folder so that it will work. Okay, so phone manufacturing model, copy to .xlsx, and then we want to get the inputs and output sheets. And I'm going to call that IO sheet because we're going to try and also go to a simulation sheet as well. So IO sheet, and again, B4 was the number of phones, and we can see we indeed get that same number of phones. And if we just put some other value there, and then we run that, we can see it updates the number of phones over here, which changes the MPV down here. So then the other side of this is going to be getting the MPV, which the MPV we can see is in B24. And so we can pull that value and we see we get the MPV here coming into Python. And I'm going to take the float of that since it's coming as a decimal. So we can put these two things together as a function which calculates the model. So I'm going to call this function MPV, and it's going to take the number of phones and then it's going to do what we saw here. It's going to set that to the number of phones, and then it's going to return the MPV from the Excel model. So now I can call this MPV function with any number of phones that I want, and we'll see that it runs the Excel model and extracts the MPV, which we can see worked successfully. So now that we have a function in Python which runs the Excel model and gets the result, we can treat this 100% the same as having a Python model which does the same thing. So now it's the same process that we always go through with Monte Carlo simulation. We're going to want to randomly draw that input and do a loop over the number of iterations. So I can set the number of iterations here just at 10 just to get started with. I'll increase that later. And then for each iteration, well, let me first go and import random. Because ultimately we're going to do random.normalvariate of a mean and standard deviation. And let's get an interest, or sorry, endphones mean is 100,000. Endphones standard deviation is 20,000. And then we can pass those into here. And then we'll see we get different numbers of phones based on that normal distribution each time that we run this. So we're going to put that into our loop. Let's bring all this into the same cell. And then, so this is going to be the end phones. And then our MPV is going to be based upon that number of phones. And then let's set up a list for the results. And then we can append the number of phones and the MPV result. So now let's give this a try, and we'll see the Excel model run in the background. And now let's look at our results, and we can see all these different numbers of phones and the resulting MPVs. So it looks like everything is working appropriately. So now that we've got the results, we can put them into a data frame. So I'm going to import pandas as PD. And the columns here are going to be the number of phones and the MPV. And we can see that has come through correctly. So now I'm just going to convert this into a function, MPV simulations, which takes the number of iterations, the end phones mean, and the end phones STD. So I can indent all this and ultimately come and return the data frame at the end. So now run this again. We can see that now gets us the same data frame. So I'm going to go ahead and create an extra sheet over here for our simulation results. So I'm going to call this simulations. And I'm going to get access to that sheet as well. So sim sheet simulations. And now the other side of this is going to be to output those results. So sim sheet, we can put them right in A1. And we can put the data frame there. Let's give that a shot. So we'll see that we have this 0, 1, 2, 3 index thing. We don't really care about that. So I'm going to go to options. Let me first just delete this out. Options, data frame, index equals false. And then I'll try that again. And now we see we got just the number of phones and the MPV like we wanted. Okay, so now we can wrap up the Python side. Let's just put this up to 1,000 iterations. And now assign that into Excel. And now we see 1,000 iterations coming there with all the different resulting MPVs. So now that we have those simulations, now we can visualize the results. So the first thing that I'm going to do is a histogram. So I'm going to highlight all these MPVs and insert chart, go to histogram and pick that. This is the MPV distribution. And then I'm going to format axis there to now change the number of bins. We can go up to, let's say 50 bins. And so now that is a little more indicative of what's going on here. And we see there's definitely a wide left tail here and a shorter right tail. So it's not quite a normal distribution of the resulting MPV. Then we can do the percentile table. So first I'm going to create those percentiles, 5%, 10%. Then I should be able to drag the rest up to 95%. Okay. And going to do equals percentile on this entire array of values. Going to want to fix that range and then reference the percentile not fixed. We can put this in currency formatting and let me complete that down. And now we can see the percentiles of that distribution. 5% of the time it's going to be lower than 333 million. 5% of the time it's going to be higher than 390 million. So I think that was what's involved in the level 1. Oh, also output the chance that the MPV will be more than 400,000. So for that, we can create one more column here, or let me move this over. So let's create our goal here of 400 million. Can also be currency. Create a column for whether we met the goal, which is just going to be if that is greater than or equal to the goal fixed, then it's 1. Otherwise, it's 0. Okay, and complete that. So it's not in very many cases. Hopefully there are some cases here. So to get the percentage, we're just going to average this column. Which it seems that 0 met that goal. So if we move this down to 3.5 million, sure, let's put this in percent format. There we go. 82.6% are able to meet the 3.5 million goal. Even 5% are able to meet 390 million, but once you get to 400 million, apparently none are meeting the goal. So that's the level 1 exercise. Now coming to the level 2. So now we're concerned that the machine life could be different, that some machines will break down earlier than other machines, and so there's going to be variance there. And so we're going to assume that the mean is 10, but the standard deviation is 2. And then in addition to the analysis we've already done, we also want to see which of these two inputs has a greater impact on the MPV. So First, I'm going to move this over because we're going to have an additional column coming in here. I don't want this to get overwritten. And now I'm going to come back to the Python side, and there we're going to add in this new input. So not only number of phones, now it's also end life. Mean is definitely not 10,000. 10. End life. Standard deviation is 2. We can add those as inputs here. End life, mean, and life std. I'm going to add those down where we're calling it as well. And now, similarly to how we're doing this for the number of phones, we're going to do the same thing for the number of machines. Or sorry, the life of the machine. But let's take a quick look at that before we run this all the way through. Just stop. I didn't mean to run that all the way through. You'll notice when we run this that we're getting fractional lives here. And the way that the Excel model works, it's got to be a whole number of years for the life. So I'm just going to take the integer portion of that in order to convert it into a random life number, a whole number of years. So here I'm just going to wrap this in int. And then I've got to modify the MPV function as well to also take end life. And let me go back over to inputs and outputs. The number of life is B7 here. So B7 is going to get set to the life. Okay, and then that needs to get passed there as well. And we're going to want to include it in the result. And then we want to include it in the columns of the data frame, machine life. And so now, hopefully everything works appropriately here. We can see the Excel model is running. I hope that's not full speed. Yeah, this is something that you'll see with Excel models. So I'm going to stop this here. As soon as you start adding visualizations, it really slows down the calculations. So I'm going to delete this chart and see if that allows it to run quicker. Now I can go back over to inputs and outputs and try this again. Still seems to be running slow. So it could be all these additional calculations I've done on these simulation results. Let me just quickly try this with 10 to see, is that really the speed it's running? No, it was a lot faster than that. So the speed that we're seeing here, we're not seeing every run of the model. Okay, 100 finished in not too much time. So I am going to go ahead and just run for 1,000. It'll take a little bit to run, but nothing too crazy. So then once this finishes, we're going to do two things here in Excel. Well, we've got to output our results back to Excel. And then the two additional analyses that we're going to look at are running scatter plots on the number of phones and the life of the machine versus the MPV, each individually. And then going to run a regression, a multivariate regression which is looking at the effect of these two variables on the MPV. So it's just finished up with the simulations. I'm going to come back over to the simulations tab and write those values in. So now we can see we have 1,000 with different machine lives. We can update this met goal over here to this MPV so we can keep this updated. Now we see 24% chance now that the life of the machines is changing too. And we can also update this to come back over. And we see, a lot more variability in the MPV now that we're varying the life of the machine as well. And we would want to bring back the graph, but I'll save that for the sake of time. So now we're going to add the scatter plots. So we want to look at the number of machines versus the MPV. We're going to insert recommended chart. The scatter is what comes up first. And we do see some interesting patterns here. And I think this is basically the different numbers of machines, what each, basically each one of those, we see kind of a linear, slightly curved relationship with the number of machines within each machine life. This is MPV versus number of phones. And this definitely seems indicative of a relationship. There are very clear patterns here. Now we can do the machine life versus the MPV. Here again, a scatter. And there we see also definitely an interesting pattern again because there are only integers allowed for the number of machines. Basically, each time we get more machines, we get more MPV, but then we see this whole different range of MPVs for the different numbers of phones that are occurring within those cases. So definitely seeing a relationship here as well. And this would be MPV versus life of machine. Okay, so then the last that we want to do is the multivariate regression. And we need to use the data analysis tool pack to do that. You can see I do not have it enabled here. So I'm going to go File, then Options, then Add-ins. This is built into every cell, but you do have to enable it. Analysis tool pack. Yeah, I've been having this bug. It showed as enabled for me, and now it's still not there. Now I go back in, File, Options, Add-ins, Manage, Excel Add-ins, enable it, and hopefully it will show up this time, which it did. Now we have data analysis over here. So we click data analysis, and we have a bunch of options here. We want regression as the option. And the y is going to be our outcome variable. So that's going to be the MPV. And the x is going to be both of these other variables. And notice I did grab the headers here, and so I'm going to check that it does have labels. And sure, we can output it in a new worksheet. So hit OK. And now we have our results. So now we have that the one additional phone is going to increase the MPV by $872. And we have that one additional year of life of the machine is going to increase the MPV by $42 million. But in assessing which has a greater impact, we still need to consider the standard deviations of each of these. So I'm going to go and get the standard deviation of the number of phones. Which should be about 20,000 because that was our input in the simulation. And then I'm going to go get it from the machine life. It should come to about 2. Okay. And then get the standardized coefficients. Where we just multiply the coefficient by the standard deviation. And this allows you to directly compare across the coefficients. So this is now saying that a 1 standard deviation increase in number of phones leads to a $16 million increase in NPV, and a 1 standard deviation increase in machine life leads to an $85 million increase in NPV. So based on the distributions that we have for the inputs, the machine life is quite a bit more impactful on the NPV, roughly 5 times more impactful on the NPV than the number of phones. So that covers everything for this lab exercise and running Monte Carlo simulations on Excel models using Python to run the simulation, but then analyzing the results in Excel. So thanks for listening and see you next time.